Good morning friends. Today we are going to see the next topic, that is the superposition of wave. Friends, in last day we have completed the topic oscillation. We are going to see the numericals later on. First we are going to complete the theoretical part. Friends, today we are going to start the superposition of wave, that is the topic number 6 from section 1. First we will see the introductory part. So when we are studying about the waves, we should know what is meaning of wave. The oscillatory disturbance created in the material medium is known as a wave. For example, if there is a one pool having completely filled with water, and if we drop one stone, then the vibrations are created, and these vibrations created on the surface are nothing but the waves. So the medium is at the rest position, but the disturbance is created, and that disturbance is responsible for formation of waves. Again, if we have a stretched string, so that will be at the rest position. If we plug it, then waves are created. So the medium will be at the rest, but after plugging, the waves are created. So that is a wave. So the oscillatory disturbance, and if you observe the disturbance, particle will be going in the upward direction, at the same time it will move in the downward direction also. So what we can say, that the vibration of the particle is in the upward as well as in the downward. So it is one kind of the oscillatory motion. So that is the definition of the waves. So again I am going to repeat the definition of the waves. The oscillatory disturbance created in the material medium is known as a wave. So we have studied the different kinds of the waves: sound waves, light waves, mechanical waves, electromagnetic waves. Such kind of the different waves are present there. So out of these, first we are going to see about the mechanical waves. So what is meaning of the mechanical waves? The mechanical waves, the waves which require the material medium for their propagation, is known as the mechanical waves. If we drop the stone in the water, so generally it will be in the format of the wave. Here the particle will vibrate in the upward direction, at the same time the particle will be vibrating in the downward direction. Here the particle do not change its position. Particle will remain at the same position, but if we are looking, we can observe that the particle is moving. So remember, when we are saying about the mechanical waves, in the mechanical waves there is a no transfer of matter, only energy will be get transferred. So what is mechanical waves? The waves which require the material medium for the propagation is known as the mechanical waves. In mechanical waves, energy will be transferred, but there is a no transfer of matter. Example, sound waves. So when we are saying about the sound waves, then the formation of compression, the rarefaction will take place, and the particles will be vibrate about their mean position, and one particle will transfer energy to the other. Again, in order to understand this, we can take one simple example. Suppose the students are sitting in a row. On the first bench, I have given a notebook. Then we have to pass this notebook from first bench to the last bench. Then the first student will give the notebook to the second, second to the third, third to the fourth, and then notebook will reach to the last bench. Here the students haven't changed their position, but the notebook will be transferred. Same thing will be happen in the mechanical waves. Means the particle, means the students will remain at the same place. Means there is a no transfer of the matter, only energy is transferred. Means only the notebook will be traveled. So this is regarding the mechanical wave. So the example of mechanical wave is the sound waves. Again, electromagnetic waves. So in standard 11, you have studied the whole topic regarding the electromagnetic waves. So I am not going in detail. Just will see the definition part and one example. So what is electromagnetic waves? So electromagnetic waves are also one type of the mechanical waves. So here also there is a transfer of energy, but there is a no transfer of matter in the electromagnetic waves. So what is the definition of the electromagnetic waves? The waves which do not require the material medium for their propagation are known as the electromagnetic waves. So electromagnetic waves have the capacity to travel through the vacuum. And in standard 11, you have studied that the speed of the electromagnetic waves is equal to as that of the speed of light. that is a 3 into 10 raised to 8 meter per second. So the example of the electromagnetic waves is the formation of X-rays. Friends, in this topic, superposition of waves, we are going to see some interesting phenomenon of light like reflection, superposition of waves, formation of stationary waves, beats and its application. So this part we are going to study in this topic. Friends, this part is quite lengthy. Here some theory and as well as some equations are there. So theoretical part I have just only on the point basis. You have to make a complete sentence, and whenever there is a equation part, there also I am going to write only the mathematical part, and remaining theoretical part or the explanation you have to write in your own words. So as per the suggestions given by me, or you can take the reference of the textbook there while making the notes. So remember, I have done only the important points. You have to make a complete sentence, right? Okay, so now we'll begin the topic with the first point, that is progressive wave and its properties. So what is meaning of the progressive wave? So initially I have told you the same example that if you drop the stone in the water, then the ripples are created on the surface of water, and after some time it will vanish. So the ripples are traveling continuously. So we can say the wave which travels continuously in the given direction is known as a progressive wave. So what is a progressive wave? The wave which travels continuously in given direction is known as a progressive wave. Now we'll see its properties. At least 4 properties you should know regarding with the progressive wave. First point regarding with the progressive wave, or first property of the progressive wave, is that in the progressive wave each particle will be in SHM. So what is the meaning of SHM? SHM is a simple harmonic motion. So each particle in the progressive wave will perform the simple harmonic motion. So that is the first property. So simple harmonic motions means it will be just like as a sine waves. You can see that it is moving upward as well as the downward, again upward and the downward. That kind of the motion we can say regarding the SHM, simple harmonic motion. The second point is that the progressive waves particle have same amplitude, period and the frequency. So amplitude of the particle, period and the frequency are the same. So you know the definitions of the amplitude, period and frequency. Maximum displacement of the particle from the mean position is known as amplitude. Period, the time taken by the particle to complete one oscillation is known as the period. And frequency, number of vibrations completed by the particle in 1 second is known as frequency. So we can say that in the progressive wave, the particle have same amplitude, period and frequency. That is the second property. Next, the phase changes from particle to particle. So here you can observe I have taken the sine wave here, here, here. So at every point there is a phase change. So that is the next third property. Fourth property, no particles remains in the rest. At every point the particle will be in the motion, whether it will be in the upward direction or whether it will be in the downward direction. The maximum velocity of the progressive wave will be at the mean position. So that is the fifth property. Next, when the progressive waves travels to the medium, at that time energy will be get transferred, but no matter will not be get transferred. Next property, this says that the progressive waves are of 2 types. They are the transverse waves and the longitudinal waves. So these are the properties regarding the progressive wave. At least 4 properties you should remember. Friends, here is the transverse waves and the longitudinal waves. So in short, I am going to explain you what is the meaning of the transverse waves and what is the meaning of the longitudinal waves. Standard 11, you have got the little bit idea regarding to the transverse waves and the longitudinal waves. Here I am going to explain once again. Transverse wave. the wave in which the particles of the medium vibrate in a direction perpendicular to the propagation of the waves is known as the transverse waves. Again, I am going to explain transverse waves. The waves in which the particles of the medium vibrate in the direction perpendicular to the propagation of the wave is known as a transverse wave. When transverse wave travels through the material medium, then the formation of the crest and trough will take place. So crest is the uppermost part and trough is the lowest part. The distance between the two successive crests or the distance between the two successive trough is known as the wavelength and is denoted in the symbol lambda. So this is the information regarding the transverse wave. Next is the longitudinal waves. Longitudinal waves. What is the meaning of the longitudinal waves? The waves in which the particles of medium vibrate in a direction parallel to the propagation of the wave is known as the longitudinal waves. The waves in which the particles of the medium vibrate in a direction parallel to the propagation of the wave is known as the longitudinal waves. When the longitudinal waves travel through the material medium, then the formation of the compression and rarefaction will take place. So compression are those points where the particles are very close to each other. Rarefaction is those points where the particles are away from each other. Here also the distance between the two compression or the distance between the two rarefaction is known as wavelength. So this is about the longitudinal waves. Again, I am going to explain in short about the transverse and the longitudinal waves. The waves in which the particles of the medium vibrate in a direction perpendicular to the propagation of the waves, then the waves are known as the transverse waves. When the transverse waves travel through the material medium, formation of the crest and trough will take place. Longitudinal waves, the waves in which the particles of the medium vibrate in a direction parallel to the propagation of the waves, then such kind of the waves are known as the longitudinal waves. In the longitudinal waves, formation of the compression and rarefaction will take place. So friends, today we have seen the introduction part regarding the topic. After that, we have seen the definition of the progressive wave and its properties, and at last we have seen the transverse waves and the what is meaning of the transverse wave and what is meaning of the longitudinal wave. So friends, I hope you have understood the today's part. We try to make the proper notes. Thank you. Have a nice day.